So again, we're going to work with combining like terms. We're just going to keep on keeping on with that. First one, keep on keeping on, Corbin. All right, the first one is a true or false, and it says select all the statements that are true. So let's go through each one of these and say if they're true or false. All right, this says 4 minus 2 times 3 plus 7 equals 4 minus 2 times 3 minus 2 times 7. What do we think about that one?
It's not.
I don't like it.
Who thinks true? Nobody?
You just said yes, Jared.
Everybody thinks false?
I said no.
All right, well, what are we going to have to do with this 2?
Distribute it.
We're going to have to distribute it. So we take 2 times 3 and 2 times 7. How do we feel about it now?
Yes.
I think it's still true.
All right, because if we take 2 times 3 and 2 times 7, that's just what we did over here. They just laid it out a little different. So what do we think about this one? It's going to be true because we just distributed.
I think all of them are going to be true.
All right, let's find out.
I think all of them are true.
The second one is true.
We think the second one's true?
It is.
Why is it true?
Because you're just adding negatives.
Because adding a negative is the same as subtracting, right? Subtraction is adding the opposite. Corbin, Kinley, you with me?
Yeah.
All right, so the second one's true because adding the opposite is the same as subtracting. All right, how about 3?
No.
Evan says no.
No.
Say yes. It's true.
I don't
Evan,
like
why
it.
no?
I don't like it.
It's true.
Josh doesn't like it?
I don't like it. It's criminal.
It's treason.
Let's look at this adding sign right here. Evan says this makes it not true. Anybody agree or disagree with Evan?
I agree with that. Okay, what? Because on number 2, it was adding -2.
Because he's
And on number
adding, I'm
1,
gonna
it
disagree.
was subtracting 2. But
All
on
right.
this one, you're adding 2 just in general. You're not like.
So these are the same. 1 and 3 are the same, right? And if we said 1 was true and we're minusing 2 times 7, how would this one be true?
It's not.
Exactly.
It's not. So this one would be false.
I just forgot the little piece on that.
All right? They just changed that subtraction sign to an addition sign. That would make this one false. We okay there?
Yeah.
All right, the last one now. What do we think about the last one?
No.
Josh says no.
Because
Sophie says no.
operations, you have to do 2 times 3 plus 2 times 7 minus 4. Then it would be messed up.
But these are in parentheses.
So it's okay. Maybe.
I don't like it.
Just doesn't like it.
Feeling in my head.
Georgia says it's true.
It's true.
Brooklyn says it's true.
I don't like it.
All right, well, let's talk again. You guys with me here? A lot of side conversations going on. Can we stay dialed in, please? All right. So what do we have to do with this 2? We already talked about it. We got to distribute it. So now over here, we're just taking each term in the parentheses times 2. Is that distributing?
Yeah.
And we have the correct sign here, right? We're still subtracting. So now what do we think about that one? It's going to be true. Because this sign is wrong right here.
There's an audience sign in that one though.
But we're adding the opposite.
Okay.
He's right, you're wrong. Just move it.
No, this one. There's an audience sign right there and there. Yeah, this is.
But we're adding the opposite.
I think we should make a protons on this.
Yeah.
What is with you and
Let's go.
Alright. So adding, subtracting is the same as adding the opposite, right? You're okay with that?
We should quit that and then we should go like.
So
I'm pretty sure you
x minus 2 would be the same as x plus negative 2.
Well, we have,
Those are the same thing?
we have a math teacher.
So in this one, we're adding the opposite. We're adding a negative 2 instead of subtracting. This one, we're just adding 2. Is that better now? Okay. All right, any questions on that one, guys? Jared?
What did you have to, I thought you had to add the things in the parentheses first and not distribute the 2s.
Yep.
But like,
So you distribute the 2.
4 minus 2 times 3 plus 7, I thought you had to do those first.
So you're saying order of operations, the parentheses come first?
Yeah.
When we have this 2 outside the parentheses, we distribute, that goes along with the parentheses. So we're still operating under parentheses in our order of operations. So we distribute first and then add the parentheses. Does that make sense? So
Yes, it does.
the number out front in PEMDAS or in our order of operations is paired with the parentheses there. All right? 21-2. All right, I'm going to let you guys work on this one on your own for a little bit. All right, it says some students are trying to write an expression with fewer terms that is equivalent to 8 minus 3 times 4 minus 9x. So Noah, Lynn, Andre, and Jada all tried to simplify this expression, but only one of them did it correctly. So why don't you guys go through and see if you can figure out who did it right.
Why can't they figure out that one time?
All right? What would be a good way to check?
Solve it. That's pretty much a good way, yeah.
Not solve it. How could we check if this would be equal to any equation? What could we do? Not factor.
Do the things to the numbers.
We could plug a value in for x, right? So if we plug a value in for x here,
X equals 2. Yeah.
sure, if you want to plug in 2, you can plug in 2 and then check each of their equations to see who got it right. If you get the same thing, then they got it right. If you get something different, they did something wrong. All right, so for number 1 there, tell me who you agree with and then explain why you agree with them.
What does it mean fewer terms?
Like less numbers.
Less phrases.
All day? Oh. It was a question, man.
Wow. You immature. Oh. Everyone that answered one of four.
Thanks, Josh.
I have the real answer, Josh. Oh, no.
Wait, who do you think it is? A person?
No.
I think it's Diego.
Yeah, she thinks it's. I just said that because he has at least an amount of. And I don't really get what it is.
Oh, yeah, it's obviously Lynn. Like, it makes the most sense.
I bet it's Noah.
It's Diego.
Of course, I forgot about Diego.
No, it's Joe, guys.
Guys, it's definitely not this one.
Honestly, these people are making this more hard.
Josh, which one is it?
It's Joe.
I bet it's Andre.
I'm not gonna fall for another
I don't know how to say, but I think Andre's right.
I would call back.
Noah back.
Yeah, me and Charlie do.
That's cute.
I was literally trying to do my thing. Yeah, they are the same person.
Josh, when you're right, I'll bring you a cookie or something. You were when?
You remember when you were like?
Yeah. It's gonna be one of those cookies that's filled with peanut butter. Or with the peanut butter chocolate chips and all that. Oh, wait a minute. Oh, I guess I'll have to eat that one. Sorry, man.
No, we're still gonna give it to her.
I'm kidding. It'll be a chocolate chip. You like chocolate. No, he's just mad at me.
Everybody have an answer on those? Alright. Well, I hear a lot of other stuff going on, so let's get back to class.
Not Andre, guys.
Alright. Jared, who do you think?
It's
None
none of them.
of them? Jonas, who do you think? Think it's Lynn. We got one for Lynn. Chesney, who do you think? Think it's Noah? Noah? Alright, let's do this. Who thinks Noah? Couple of us.
No, Josh thinks it's no.
Who thinks Lynn? Couple of us. Who thinks Jada? Just Colin?
Jada's wrong, though.
Alright, who thinks Andre? Couple of us.
Who thinks none?
Watch Colin be right.
Question?
Watch
I
Colin be
just
right.
said, I shouted out who thinks none and I raised my hand.
Okay, my bad. I forgot, Jared. I forgot your opinion. Alright? That's on me. The person we should agree with
None.
is Jada.
Yes, I knew it. I called it.
Alright?
I said I called it.
Alright, let's talk about it then, so it does make sense. Are you guys with me? Let's talk about it so it does make sense then. If we're going to distribute here, what do we distribute? We're going to take the 3 first. Alright? So what's 3 times 4? What's 3 times 9x? Alright, now we got to distribute this negative. We're not done distributing yet. So now we distribute the negative. So we get 8 minus 12. And when we subtract a negative here, what happens? We would add. So now we have 27x minus 4. Is everybody okay with how we got there? Or is that still a little hazy? All right, and now if we want to check, what do we want to plug in for x? 1. All right, so what's 4? Well, we got to distribute. What's 12 minus 9? 3. So 8 minus 3? That ain't going to work. All right.
I think we need to hurry up so we can play more High School Musical.
All right.
Keep it going nice and slow.
All right.
We're like construction workers that get paid by the hour, so they make it super slow.
Yeah, I listened to it every day in theater.
You probably haven't even seen it.
All right, so we plug in 1 here. Look, if you guys are going to keep talking about other stuff, we're not going to get to work on our homework, and we're not going to get to do High School Musical. So you got to stay with me here.
Okay, we gotta go.
All right, I know Mr. Milbrat's gone, but you got to stay with me. Doesn't give us an excuse to just goof off and talk around. All right? All right, so if we plug in 1 here, we have 9. This will just equal 9. We still got to distribute our negative 3, our 3 and our negative.
We can't see it.
So if we distribute that 3, now we have 8 minus 12 minus 27. All right, and then we distribute that negative again. So we have 8 minus 12 plus 27 because we'd be subtracting that negative. We all okay with that? So 8 minus 12 would be negative 4. Negative 4 plus 27 would be 23. We all right with that? All right, if we check here, 27 times 1. 27. What's 27 minus 4? So those check out. We get the same thing. All right, we okay there? Now let's go through. For 2, it says, for each strategy you disagree with, let's find and describe the errors. So what did Noah do wrong? Chesney, what did he do wrong? He subtracted first. He didn't do his order of operations. All right, so instead of doing the parentheses first, he subtracted, and that changes everything. That changes our whole answer. All right, what did Lynn do wrong? Sophie?
It was supposed to be 8 plus negative 8 plus 4.
Not quite. Before that, she did something wrong before that. She did something we can't do. Can you combine 4 minus 9x? Well, she did.
That's exactly what I didn't do.
So you can't do that. You can't combine like terms or non-like terms. You can't do 4 minus 9x. All right, so that's what she did wrong. All right, what did Andre do wrong? one's a little trickier to see. Got it, Sophie?
He didn't distribute the negative.
He didn't distribute the negative, right? Because if we would take a negative 3 times negative 9, what kind of number are we going to get? We're going to get a positive, right? Here we still have a negative 27x, or minus 27x. So he took negative 3 times negative 9, and he got negative 27. Is that right? No, that doesn't work out. All right, we all okay with those mistakes? And how that can change our entire equation or expression? All right, let's talk about grouping on 21-3. Kinley, you want to read that one for us?
Sure. Diego was taking a math quiz. There was a question on the quiz that had the expression 8x minus 9 minus 12x plus 5. Diego's teacher told the class there was a typo and that the expression was supposed to have one set of parentheses in it. Where could you put the parentheses in 8x minus 9 minus 12 plus 5 to make a new expression that is equivalent to the original expression? How do you know that your new expression is equivalent?
All right. So on this first one, it still wants us to be equivalent. So when we put our parentheses in here, it can't change our outcome. We still have to get the same thing. So for this first one, there's 2 spots you could put parentheses to make the same expression. Kellen, you know where 1 would be?
Is it 12x plus 5?
It's not 12x plus 5. Georgia?
9 minus 12x.
Not quite there. All right, these might be a little tough to see since we haven't worked with that. Jonas?
Is it 8x minus 9?
We would put 1 around 8x minus 9. That would keep the same. All right, and the last part of the question says, how do you know that your new expression is equivalent? How could we check that? What could we do to see if this is the same as this? Could plug it in. So for this part, we can plug in a value of x. All right, and then there's one other one. It's kind of obvious. Chesney? I think this one's it's a little bit different, so you might not see it right away. And it's kind of cheating. But to make this the same, you can just put it around the entire thing, right?
That's treason.
It doesn't really do anything, but we could do that to keep the expression the same, right? So that one's a little outside the box. All right? But if we wanted to check this, we could plug in a number for x, and we would see that this is the same as this. We'd get the same answer. All right, so number 2 says, where can you put parentheses in this thing to make a new expression that is not equivalent? So, Kellen,
12x plus 5.
you could put them right around there.
See, I was right, I just wasn't.
Right.
You were right on the wrong problem.
Exactly.
So that would give us a different expression or a different answer. Jared?
Put the parentheses around one number.
That wouldn't really change anything. So that would work for up here. All right.
Parentheses around 8x and 12x. Like from 8 to 12.
Put it around the whole thing so you could say
No, but wouldn't that be the same?
That.
that would be different. That would give us a different answer. All right, there's one thing I want to talk about that we can do, and it's going to give us a different answer. But we can split up terms if we want to. It's going to change everything. So this would work for this question. But if we wanted to, we could put a parenthesis right there. So then what would we do?
8 times x minus 9.
You'd have to distribute that 8, right? That's going to completely change everything from this equation to this equation, or expression. But we can do that. That is a legal move to put a parenthesis in there to break up a term. So for this one, this would change everything. All right, we okay there? All right. Let's talk about the Are You Ready really quick. All right, I just want to do 1 and 2. All right, the Are You Ready? We're going to go back. All right, so Jada's neighbor said my age is the difference between twice my age in 4 years and twice my age 4 years ago.
So this is a lady that doesn't want to.
All right, so we're going to figure out her age. So how would we show twice her age in 4 years? How could we show that? Chesney? Not times, it'd be plus. Right? So 2x would be twice her age. Plus 4, because 4 years in 4 years. All right, so we have 2x plus 4. And it says difference. So we're going to subtract from twice my age 4 years ago. How would we show that now, Chesney? 2x minus 4. All right. We all okay with that? All right.
Where were you?
All right, and I messed up on this parentheses here. It should go right there. The 2 should be outside the parentheses.
You can have the last cookie if you want.
The 2 should be outside the parentheses, so we distribute that 2. All right, if we do that, we get, if we distribute this 2, let me rewrite this. I kind of made it sloppy. All right, now if we distribute our 2, what would we get? We get 2x plus 8 minus 2x minus 8. All right, so what's 2x minus 2x? 0. Those cancel out. And now what's 8 plus 8? So she's 16 years old. That's how we figured that out. That would make it a lot easier. All right, so now for the same thing.
Or you could just say I'm either 15 or 16.
For 2, it said another neighbor said my age is the difference between twice my age in 5 years and twice my age 5 years ago.
Why have you done this?
So it's the same thing. We just changed the number of years, right? So what would our expression look like on this one? Chesney? Yep. And minus 2x minus 5, right? So if we distribute on this one,
2x plus 10
all right, that would be a plus because this negative gets distributed too. So now we have a minus 2x, or we could say plus negative 2x. And now the negative times the negative 5, negative 2 times negative 5 is positive 10. Okay there? So now 2x plus negative 2x. Cancel out, that's 0. And what's 10 plus 10? So the other neighbor is 20 years old.
Why can't they just say they're 20?
That would make it easy, right? All right, let's talk about the homework. All right, the first one gives Noah says that 9x minus 2x plus 4x is 3x because the subtraction sign tells us to subtract. And Elena says 9x minus 2x plus 4x is equal to 11x because the subtraction only applies to 2x. Tell me which one you agree with and why there. All right, so if we were to simplify this, what would we get? And tell me who you agree with and why. All right, so if we combine those like terms, who would be right? 2 said identify the error in generating an expression equivalent to this expression here, then correct the error. So it's telling you there's a mistake in here somewhere. Somehow in this simplification they messed up. You got to find that error and then fix it. All right? 3, we did one like this yesterday. It says select all the expressions that are equivalent to this expression here. So go through each one of these and tell me if it's equivalent to here. All right, the next page we have 4. It says the school's marching band has a budget of up to $750 to cover 15 new uniforms and a competition fee. That totals $300. How much can they spend for one uniform? So this one, I'll tell you, you're going to write an inequality. All right, we're going to write an inequality on this one. They have $750 to spend, and they want to figure out how much they can spend on each uniform. All right, we know they already spent $300 on the competition fees, so we got to figure out how much they are allowed to spend, or how much they can spend at most on each uniform there. So for A, write an inequality there. And then B, solve the inequality. So tell me what X would be. 5, it gives you an inequality and says solve the inequality that represents each story, then interpret what the solution means in the story. So it gives you the inequality on each of these and the story to go with it. It wants you to solve that inequality and then interpret what the solution means. So tell me what X means relative to the story. All right, and then the last one, 6, it says a certain shade of blue paint is made by mixing 1.5 quarts of blue paint with 5 quarts of white paint. If you need a total of 16.25 gallons, it does say gallons, but they messed up here. So we're going to change this to quarts. All right, it's supposed to say quarts. So everybody change that to quarts, otherwise you're going to get a completely different answer. We all good that that's supposed to be quarts? Everybody got that down? All right, so we're looking for 16.25 quarts of this shade of blue paint, and it wants to know how much of each color you mix. All right, so how would we figure out our ratio there? How would we set that one up? Do we know how to start this one? We're looking to make this much. We're looking to make this much paint of this new mixture. So we're going to start with that. I'm going to start with 16.25. And how much was in the original mixture? All right. So what would we do with these two numbers to figure out how much we divide? All right, so that should get you started on that one. Is this our final answer? No, because it wants to know how much of each color. All right, so this will tell you how much total paint you make, but then you got to figure out how much blue paint and how much white paint on that one, all right? All right, so we got about 8 minutes left of class. Should give you a good head start